Okay, so here's an example I want to work, and I want to say this as well. Let me back up to the previous example. On the previous one, I got the integral from 1 to infinity of 1 over x squared dx converged to the number 1. That indicated that the series also converges, and I want to mention this, but the series is not the number 1. But see, that's what the integral converged to. But the series does not necessarily converge to the same number. So I don't know what the sum is at this point. So anyway, let's work the next example. So I have the series as n goes from 1 to infinity of 1 over the cube root of n. Well, the first thing I want to do is write this cube root of n. Instead of a radical, let's write it as an exponent. What's it going to be? N to the 1/3. So the sum as n goes from 1 to infinity of 1 over n to the 1/3. I will model this with f of x equal 1 over x to the 1/3. Is f of x continuous on the interval from 1 to infinity? Where is it discontinuous?
0.
At 0. So it's continuous from 1 to infinity. Is it positive? Yes. Here, I might put a little question mark there. Continuous? Yes. Positive? Yes. Is it decreasing?
Yes.
Yes. Some of them are obvious that they're decreasing. Some of them are not quite so obvious. And if it's not obvious, well, then you should use this tool you had last semester when you were doing all those graphs. How did you determine if a function was decreasing? You did that first derivative. You picked test. You found where the first derivative was 0 or undefined. You picked test numbers, and where in the intervals where the first derivative was positive, then that was what? Increasing. Okay, where the first derivative is negative, then the function would be decreasing. But anyway, that's this one is decreasing. So we can use the integral test. So we'll find the integral from 1 to infinity of 1 over x to the 1/3 dx. I will write that as the limit as t approaches infinity, the integral from 1 to t, and I'm going to just go ahead and say x to the negative 1/3 dx. So let's do the antiderivative. This will be the limit as t approaches infinity. X to the negative 1/3, add 1. I'll get x to the positive 2/3. Multiply by the reciprocal, 3/2. And we're going from 1 to t. So that's the limit as t approaches infinity of 3/2 t to the 2/3 minus 3/2 times 1 to the 2/3. As t goes to infinity, what's happening here? The second part's 3/2, but that's going to be infinity. That's infinity. infinity minus 3/2, infinity, and I wrote equals infinity. Now, technically, I should maybe just say, what? Diverges. The integral diverges. So, what about the series?
It also doesn't.
Also diverges.